Hello everyone, today I'll be going through the Special Math Unit 1-2 mini quiz week 4. And well, as you can see from all this, clearly this isn't that easy of a worksheet. So yeah, let's start. So for question 1, we need to prove that tan of 3a is equal to this. So what I've done is I split up tan of 3a into tan of 2a plus a, and then I use the tan addition of angle formula to write this line as tan of 2a plus tan of a divided by 1 minus tan of 2a tan of a. And then I mean, it's not really simplifying, but I rewrite every tan of 2a using angle formulas as 2 of tan a divided by 1 minus tan squared a. So we get this mess here. And above, I made it so that, actually, let me quickly switch to color so it's easier to see. I made these two have the same denominator, these two have the same denominator, so we just times 10a by 1 minus 10 squared a and 1 by minus 10 squared a here, so we get this line up here because I'm really out of space, so I have to write from here, and then we can cancel out these two to get this, and notice how this is just the same as the right hand side, therefore we have proved it. So that's question 1. And question 2, as you can see from this, yeah, it's not friendly either. So usually in this type of question, if they straight up give you something like tan of 3a and then the question above has tan of 3a, it probably signaled you that you should probably use this. So what I've done is I've replaced every tan of 3a with the definition given above, which is, yeah, this here. And since I was really out of step, I kind of skipped some step here. All I did is basically times 10a and negative 10a by the denominator, so they have the same denominator, and basically cancel the denominator out. So give that a try, and then you'll get 3 of 10a minus 10 cubed of a plus 10 of a minus 3 10 cubed of a. So this is a cubed of a here. Yeah, really out of space. On the bottom of the fraction, we have 3 of 10a minus 10 cubed of a minus 10a and plus 3 tan cubed of a, which can be written as 4 tan of a minus 4 tan cubed of a divided by 2 tan of a plus 2 tan cubed of a. And we divide every time by 2 and then divide every time by tan of a. We get 2 minus 2 tan squared of. So from here, I don't know what I was doing. I accidentally rewritten every single a term as x. So whenever you see an x, just assume it's a capital A. So we have 2 minus 2 tan squared of x divided by 1 plus tan squared of x. And notice how 1 plus tan squared of x is equal to sec squared x. The reason for that is I'll find somewhere where I have space. Let's say I'll write here. We know that sine squared, so I will just write simple notation. So sine squared plus cosine squared is equal to 1. So if we divide every term by cosine squared, then we would have, so we will have sine squared divided by cosine squared is 10 squared. Cosine squared divided by cosine squared is 1. And this is sec squared because 1 on cosine squared is sec squared. So we will have 10 squared plus 1 equals to sec squared. So that's where I got that from. So we can replace 1 plus 10 squared, this step here, to sec squared of x. And the top, we factor out the 2. And after we factor out the 2, we convert 10 squared of x into sine squared of x divided by cosine squared of x, and we can move the sec squared of x above the fraction because that's the same, because 1 divided by sec squared of x is just the same as times cosine squared of x. And we again make 1 into cosine squared of x so they can have the same denominator. So we have 2 of bracket cosine squared of x minus sine squared of x divided by cosine squared of x times cosine squared of x. So notice how these two cancels out. So we have 2 of cosine squared of x minus sine squared of x, which by cosine double angle formula, this is just equal to cosine of 2a, and therefore the whole thing is just equal to 2 cosine of 2a. So yeah, that was definitely more of a messy proof. So if there's anything you're unsure, please let me know. All right, let's go to the last 2 questions. The first one is sine of 2x equals to cosine x, and there's a really common trap for this question. So the first step is quite easy. We just rewrite sine of 2x with double angle formula and replace, and then make it equal to cosine of x. And here, this is the next step here. A lot of people will just divide both sides by cosine x, and that is not correct. and I'll show you why later. The correct way to do this is to actually move cosine of x onto the left-hand side. So we minus cosine x on both sides. So we get 2 sine of x cosine of x minus cosine of x equals to 0. So we can factor out the cosine of x to get 2 of sine x minus 1 equals to 0. So notice here how we have two options, cosine of x equal to 0 or 2 minus sine of x, sorry, 2 sine of x minus 1 equal to 0. So we can kind of rewrite that as cosine of x equal to 0 or sine of x equals to half. So if we go back to this second step here, notice how if you canceled out cosine x on both sides, you will only get sine x equals to half, but you'll completely miss another half of the solution, which is cosine of x equal to 0. So now we'll just solve these two within the given domain, and we'll get the solution, which is negative pi on 2, 3 pi on 2, pi on 6, and 5 pi on 6. So the next question, which is cosine of 2x equals to sine x, I started here because, yeah, as you can see, I don't have space. So cosine of 2x equals to sine x, we rewrite cosine of 2x as 1 minus 2 of sine squared of x. So let me see if we can zoom in a bit. So we can rewrite this line here as a quadratic equation, 2 sine squared x plus sine x minus y equals to 0. And we temporarily replace sine x as u, so 2u squared plus u minus 1, 0. We get 2u minus 1 and u plus 1 as the two factors. So either u equals a half or u equals negative 1. Therefore, either sine x equals a half or negative 1. So we solve that within the domain. So we'll get x is equal to pi on 6, 5 pi on 6, negative pi on 2, or 3 pi on 2. If you guys are unsure of how to solve these type of equations, let me know, and I can maybe arrange a individual help session. Other than that, you can probably also watch the solution for Math Methods 1-2 video this week because they have similar questions to this type of questions here. And I'll be going through those in more details there. So other than that, I'll see you guys all next week.